Welcome, welcome to software. We will be discussing basically two kinds of software: system software and application software. System software and application software. So, if you consider a computer mainly consists of two components. Two components. One is hardware. The other one is the software. So, two components are there. So, software which is present inside a computer, which can be loaded into the computer, can be broadly classified into two types: system software and then application software. All the software that is available can be put under one of these categories, either system software or application software. So what is system software? System software is the software required for running the computer and the applications. That means those that are required for actual operation of the computer, for the computer to run, and also for the different applications to run. Examples are operating system, compiler, loader, etc. They are the system software. Whereas the application software is software related to various applications which the user uses for different purposes. The user actually uses the computer for running the applications, not directly to use the system software. Maybe as a programmer you can use it, but in general common person uses the computer for different applications. User interacts with the applications, but these applications in turn will actually interact with the system software. So for these applications to run, you require system software, whereas the applications are those which are directly used by the user. Examples are the word processor, spreadsheet, video player, etc. You can use the video player to play the videos, spreadsheet for doing some calculations, Excel related things. If you are an accountant, definitely you want to do various calculations, you can make use of spreadsheet. So Microsoft supports it in the form of Microsoft Excel. So different operating systems support it in different fashions. And also the word processor where you can type your letters, etc. So all these come under application software. System software is required for running the computer and applications. Application software is one which is directly used by the user, and for running the applications you require system software. So some discussion on this system software. If you consider the system software, the most fundamental one is the operating system. Operating system has to be loaded into the computer. Without loading the operating system into the computer, you cannot do anything. Okay. So operating system is a control program and resource allocator. So operating system is loaded into the computer. Operating system controls the computer and also various other devices like keyboard, mouse, etc. And it also allocates the resources of the computer. Allocates the resources in the sense that you have CPU, you have RAM, hard disk, etc. They can be considered as the resources. Now, who is going to allocate those resources? Different programs will be competing for those resources. So you have to allocate those resources. That allocation of the resources, CPU, memory, hard disk, etc. is done by the operating system. Examples are Unix, Microsoft Windows, Mac, Linux, etc. And also this Android OS that is used nowadays frequently in the case of smartphones. They are all examples of the operating systems. So it is the first program that is actually loaded into the computer. Whenever you switch on your computer, it is the operating system which gets loaded. So without loading the operating system, you cannot do anything. So it is the first program that is loaded into the computer. The next kind of system software is computer network. Computer network is one which allows you to connect to other computers. So, and you can share the information after connecting. And of course, you can also share the resources like CPU, memory, etc. But in general, computers are interconnected so that you can share the information. Internet is an example of computer network. So computer network is a general term, whereas internet is one example. So which is based on what are called as the protocols, TCP/IP protocols. TCP/IP protocols. TCP stands for Transmission Control Protocol and IP stands for Internet Protocol. So you can say these TCP/IP protocols are nothing but, these are actually set of protocols. These are nothing but the software behind the internet. These are the software behind the internet. So the other kind of system software is computer languages. To be frank, if you want to say directly, it's not the language, it's the compiler or interpreter of those languages that come under the system software. But every compiler, every language will have its own compiler or interpreter. Maybe sometimes assembler may be there. Okay. But computer languages can be broadly classified. This is only one way of classification. Computer language in the sense that general classification at fundamental level. Again, these high level languages can be further classified into procedure oriented, object oriented, etc. We are not going at this point, we are not getting into that. So computer language can be broadly classified into these 4 types. Machine language, that is nothing but ones and zeros. Every machine will have its own machine language. Every machine will have its own machine language. That's why it is called as machine language actually. So the language of one computer may be different from other computer. Machine language in terms of ones and zeros. Assembly language, where the programs are written using what are called as symbolic codes like add, A, B, etc. That means you can write, say, add A, B. It means that add the contents of A and B. So like that, there will be symbolic codes, symbols will be used in the case of assembly language. And if you have an assembly language, you have to convert it into the machine language. Machine language is one which the computer understands because it is its own language. It understands only machine language. So if you write the programs in assembly language, you have to translate into machine language. The software which translates is called as assembler. Similarly, high level language, because you can say they are independent of the underlying hardware, they are independent of the machine. That's why they are called as high level languages. Like C, C++, Java, Python, etc. are examples of high level languages. And nowadays we have different set of protocols, different set of languages called as non-procedural languages. So in all these languages, first 3 type, particularly high level languages, you have to specify what you have to do. You have to specify to the computer what it has to do and how it has to do. Whereas in the case of non-procedural languages, you specify only what the computer has to do. Not how the computer has to do. So you don't specify the procedure. That's why they are called as non-procedural languages. Procedure for solving the problem. You don't specify it. In that case, they are called as non-procedural languages. Example is SQL, structured query language. The other 2 software that are generally used while you doing the programs is loader. You may not be directly using these programs, but they come under the category of system programs. The loader is the program which loads the user programs into the RAM. Primary memory, because program has to be present in primary memory to get executed. So programs, whenever you save them, they are present in the hard disk. But if you want to execute them, you have to transfer those programs from hard disk to the RAM. So the loader is the program which does it. Similarly, the linker is a software which enables linking of different programs. Okay, you can write your program, say large program, as one program or as multiple programs. So if you have multiple programs, and also you will be having what are called as libraries or APIs, etc. All the code has to be linked. In order to execute it. That is done by the linker. Linker links the different codes so that it becomes the single software which can be executed. Translators are actually the system software. So translator, as the name indicates, it converts from one form to other form. Because here we are interested in translators of computer languages. Here what translator does, translator converts program written in one language into another language. So there are 3 kinds of translators: assembler, compiler, and interpreter. Assembler is one which converts the program, assembly language program, into machine language. Assembly language program to machine language, that is assembler. Compiler is one which converts from a high level language program to machine language program. High level language to machine language. Similar to the case with the interpreter, but the way it works is different. You can say that interpreter is also one which converts from the high level language to machine language. So both compiler and interpreter does the same, but there are differences. So assembler converts from assembly language to machine language. These are the differences between a compiler and interpreter. So compiler converts high level language program into machine language program. So it acts on all instructions at a time. It takes the entire program as a unit and it acts on all instructions at a time. Whereas interpreter acts on one instruction at a time. And compiler occupies large space, more space, but the code that is produced by the compiler executes fast. The code that is produced by the compiler, that means the machine code that it produces, it executes fast. So you can say in other terms, compiler produces efficient code. Compiler produces efficient code. Whereas if you take the interpreter is also tries to compile, but tries to convert, tries to translate, but it may not translate it to the machine code. Translating the machine code is not ruled out, but usually the main difference is it acts on one instruction at a time. It may convert into the machine code, or it may convert into some intermediate code. Also. This intermediate code can be the source code itself. There are interpreters which directly execute the source code, or it can be some intermediate form. So it occupies less space. Interpreter is usually smaller when compared to the compiler, but it executes slower when compared to the compiler. And code producer is less efficient than the code produced by the compiler. So this is regarding the system software. Next is application programs or application software. So application programs are designed for some specific application or performing some specific task. But applications cannot run on their own. Applications require system programs to execute. The C program which you are going to write, it can be considered as one application actually. If you want to execute that application, or if you want to execute the C program, you require either compiler or for C you require a compiler. For other languages you may require interpreter. But you require a system program. These are the examples. Word processors where you can type the characters, insert characters, delete characters, insert lines, delete lines, etc. Game software, games which you are playing, they come under application software only. Video player which you use to play different videos, that also comes under application software. And expert system is one which acts as an expert. Computer system which acts as an expert, not just directly the computer system, it is the software. Expert system is a software which acts as an expert. Suppose you can design a program which takes symptoms of a patient and prescribes the medicines. Takes the symptoms of a person and prescribes the medicines. So that means it is acting as an expert, it is acting as a doctor. So such software can also be usually written using the artificial intelligence languages like Prolog. So these are the application programs. So what we have discussed now. So software is needed for the computer to operate. Two kinds of software, application software and system software. System software is one which is required for controlling the computer and also for the applications to run. Whereas applications are those which are directly used by the user, but they require system software to execute. So that differences between compiler and interpreter we discussed. Compiler and interpreter differences are important. Go through them. So compiler and interpreter differences. Some So some languages have compiler, some languages have interpreter, some languages have both. For example, C++ have compiler, whereas the AI-based languages, this Java, and then say Java also requires interpreter, Python requires interpreter, AI-based languages like Prolog, Lisp, etc. They require interpreter. But some languages use both compiler and interpreter. Examples are this Java and Python. So there is what is called as just-in-time compiler, JIT. So that is also used in some circumstances where the performance is more important. Even in the case of Python, though in many books it is written it uses interpreter. Of course, it uses interpreter, but whenever performance is required, compiler is also supported. So this is regarding the software, system software and application software. Thank you very much.